if I look at the process here, I turn on expert mode. Okay, so expert mode is turned on over here on the right. I can look at my process variables. You basically can add some new rows here. I give it a name, and you give it a value. So here I have a value for orders, and I call them 2468. And you want to be careful of the syntax. If that's expecting commas or semicolons, you have to make sure you use the same. So here I added semicolons because that's what that method requires. Here I'm specifying a tracking channel, and I can either specify it by DOF ID or channel ID. So I'm specifying it by DOF ID engine, which is nice because if the channel number changes, it doesn't matter. It's going to look for the channel with the DOF ID named engine. Then I can specify min speed and max speed. And I specified RPM here just because I know it's RPM. So if you've got a different unit or a different channel you're using that's not RPM, that's not going to work. Same thing with the speed increment, and I specified frequency resolution as well. Then I can see if I look at this method, for example. So there I've specified this tracking channel to be a design variable. If I turn that off, then I can go and pick one of these channels. Or if I hover over here, so you don't really see it until you hover. If I hover over there, this means expert mode is turned on. So I can turn that on and then pick something in the pull down, and I'm going to pick the tracking channel from my process variables. So there are defined process variables for tracking channel, min speed, max speed, speed increment, and down here for frequency resolution. Okay, so if I run this, I have the data in the input basket, so I can run this process. And if I look at my active analysis here, it's going to go through, and this is part of a drive up and a drive down. So it's just going to do the drive up portion based on the min speed and the max speed I set in the process variables. And then it goes ahead and calculates that data. So here, if I look at my differential data, here I can see I've got the spectrum map that was calculated as well as the average spectrum. Okay, so maybe if I want to reject this one and go to process variables, maybe I want to change this to be, instead of 1 hertz, maybe I want to call it 2 hertz. Okay, and then run that, and now it should repeat the process, and now it's changed 2 hertz. And it's using that in the spectrum average, as well as in the spectrum map for the vibration channels and the spectrum map for the pressure channels. It's done that, so now I can see all the data has 2 hertz resolution. I didn't really mention that before, but here I have a spectrum map, and if I check that properties, you can see here it's using the frequency resolution variable. If I check the acoustic map as well, it's using this frequency resolution variable. And if I check my spectrum average, it's using the same frequency resolution variable. Okay, so that's one way to commonize it. I reject that. There's another way to do it too that doesn't use variables, and I wanted to mention it in case people didn't know. But if I put a spectrum map, maybe add another spectrum map, I can highlight both of these now, and then I can go to the properties, and I can change settings on both of them at the same time. So here it's 2 hertz by default, so maybe I take that 8 hertz, and maybe I want this time segment to be a 0.5 second close. So now if I check them individually, that kept 8 hertz with 0.5 second, and the second one kept 8 hertz with 0.5 second. So that's another way to do it as well. If items are similar, you can just highlight them together and change the properties in one go.